Hi everyone. In my last video where I tested ChatGPT to solve the mathematical problems, if you have not watched that video, then you can see the top right corner there will be a pop-up and just click on that and then go watch that video where I gave ChatGPT some mathematical questions to test it out whether ChatGPT can solve it or not. But it was the response from the ChatGPT was great actually. So someone commented on that video. Let me show you that he said the legend 27 said, "I don't think artificial intelligence will struggle with being a calculator, but it would be interesting to solve business problems such as engineering solution to making a rocket thruster push faster." So in this video, I'm not going to solve this problem exactly, but I'm going to solve an engineering problem to test it out that can ChatGPT solve that problem or not. So for that, I picked the concept from the fluid dynamics. Let me show you the problem. Okay, this is the problem. Where is the pen? Let me select the pencil with the right color. Okay, is it working? Okay, let me increase the stroke. Okay, better. Okay, first I will try my best to explain you guys what's going on in this problem. Then I'm going to explain the problem to ChatGPT and we will see whether or not ChatGPT can give us the accurate results. So let's get started. The problem states a container, okay, filled with a water. So this is the container, okay, and it is filled with a water inside it. And there is a hole. You can see that this is the portion where is a hole. This is the portion. This is the hole, and water is coming out from the container. So as shown in the figure. If acceleration due to gravity is 10 meter per second square, what is the speed velocity of the water through that hole? So basically we have to find the speed at which the water is coming from this. Let me undo it. We have to find the speed at which the water is coming from out this hole. So we do not know the speed of the water. So basically it is the concept of the fluid dynamics. We have given a height of the container which is 1.5 meter, and we have the height from the hole to the bottom of the container is 25 centimeter. If we convert into meter, it's going to be 0.25 meter. After that, we have given a acceleration which is 10 meter per second square. That's it. We have this data. To solve this problem, we are going to use a theorem which is derived from the Bernoulli's equation. If you do not know much about it, you can just Google it and learn about it. So this is a theorem we are going to use. It's called Torricelli's law. Basically, just to give you a little bit of information about it, it states that the law explains the relationship between the fluid leaving the hole and the liquid's height in that container. So this is the exactly problem we are trying to solve. So that's why that law is suitable to use here. This is the derivation that Torricelli's theorem states, which is derived from the Bernoulli's equation. In this equation, where v is the velocity of the fluid, g denotes gravitational acceleration, h is the shows liquid's height over the reference point. This is a very important point. I'll explain that in a minute. So, and this is the density, and P is equal to atmospheric pressure. So after solving that and assuming some conditions where H is 0 and P is the atmospheric pressure at opening H is 0. So after calculating, he come to the conclusion of this equation. We are going to use it now. There is a question, why did he take this portion of the height, why not the full height? To explain it a little bit, it says that the theorem itself says that h shows the liquid's height over the reference point. So here our reference point is this hole. We want to find out the velocity at this point, so we are taking this as a reference point. Okay, so after plugging the formula in, the actual formula was v is equal to under root 2gh. So when we take in square on both sides, this under root will be cut out, and we left with v squared is equal to 2gh. After putting the value in it, we will get 5 meter per second. So we know that if we have a container with 1.5 meter height and there is a hole at 0.25 meters, the velocity of the water at which that water is coming out from the hole will be 5 meter per second. This is the problem. Now I'm going to state the same problem to the ChatGPT. Let's come here, go to ChatGPT, openai, and if you have not already created an account there, just create one. Let's state our problem. Okay, I want you to solve this problem related to fluid mechanics. Now I'm going to state the problem. There is a container filled with water. The height of the container is 1.25 meter, and there is a hole in that container. There is a hole in that container at 25 centimeter from the bottom of the container. Okay, I want you okay, let me also mention the gravitational force that is acting on the fluid is 10 meter per cc, second square. Okay, we have given all the information to the ChatGPT. Now I want him what I need. I want him. Okay, so I want you to tell me the velocity of the water coming out from the hole. Please explain each step in detail. Okay, is there anything else I want? Okay, let's see what ChatGPT can do. To determine the velocity of water coming out of the hole, we can use the Bernoulli's equation. This equation states that the sum of kinetic. Okay, this is the Bernoulli equation. First, we need to calculate the pressure at the bottom of the container, which is the point where the hole is located. This pressure is equal to the density of water times the acceleration due to gravity times the height of the container. So P bottom is equal to rho into G into height. Okay, density, this 1000 kilogram per meter cube is the density of water into the value that I gave him about the acceleration. Okay, where I am, and then height that I define it from the bottom of the container. So it as you can see that I just states 25 centimeter. It is intelligent enough to convert that unit into a proper unit, like into meter. So this is one of the impressive point, because when I was in my in university, sometime I made a mistake about these conversation. I did not convert it into proper unit, and obviously my answer was wrong. So this is like a fantastic move. Anyways, so it calculated the pressure at the bottom, and then next we need to calculate the pressure at the point where the water is coming out of the hole. Since the water flowing out of the hole and there is no change in elevation, the pressure at this point is equal to the atmospheric pressure, which is proximity of this. Now we can use the Bernoulli equation to calculate the velocity of the water coming out of the hole. The equation states that P bottom rho, okay, half density V bottom square equal to P. Okay, this is the Bernoulli equation, where V bottom is the velocity of the water at the bottom of the container, and V exit is the velocity of the water coming out of the hole. Substituting the values we have, solving the equation for V exit, we get V exit, okay. So velocity of the hole is like 14 meter per second. This is the theoretical velocity. In reality, it could be different due to viscosity of water and roughness of the hole. Okay, it uses Bernoulli's equation. I'm not sure about this because I don't have, like, deep knowledge into this. Let's say that use the above problem using, what was the name of the law? Let me copy this. Turn law. Let's see if it can solve this equation using that specific law. Yes, exactly. Now it's using that what was the name, Torricelli's law. Now the answer will be, I hope it will be 5 meter per second. Well, it's not exactly 5, it is approximately 5. So it's V exit square root 2 into 10 meter per second square into, okay, this is the height, and this is 10. I'm not sure why did it multiply it with 2. What is 2 here? What is 2 here? I'm not sure. Let me see the formula. What's the formula here? It's called the velocity. Okay, it's in the formula itself. Okay, 2 is in the formula. So 2 into g into h. So when it multiply 20 meter square per, and then square root of 20 is equal to this, the velocity of the approximately meter per second. Theoretical value, it could be viscosity of the water. No. I mean, this is amazing. Now I just told him to use this Torricelli's laws. It used exactly the same law and obviously the same steps to give us the same answer. I'm sure, I did not calculate this problem, but it gave 25. 1.5 meter is the height. What did that states in my problem? Oh, okay. I changed the height of the container. It's 1.25, whereas in actual problem it was 1.5. So that's why here the answer was 5, and we have like 4.4, which is the correct answer. This is the correct answer based on our problem, because I stated the height of the container 1.25. Let's update that height only. I mean, this is very amazing that the ChatGPT has a memory. It records what we type in. So let's change the height of the container to 1.5 and use, let me copy paste Torricelli's law to solve the problem. I mean, this is a great tool. If you explain him like what you need, it's going to do it but obviously it will, improve itself over time. But now, at this point, it's like mind blowing. It's solving proper engineering problems. Amazing. So let's come on. Okay, now you can see the answer is 5 meter per second. This is, mind blowing. I mean, I can also tweak this problem a little bit. Let's say if I want to know, not if I want to know the time, let's say that I want to know that in how many minutes this container will become, become half of its no, not half, but let's ask ChatGPT a question. Tell me tell me the time in which the water stop the water height, okay, in which the height of the water become half. Tell me the time in which the height of the water become half. To determine the time it takes for the height of the water in the container to become half of its original value, we use the principle of continuity and the conservation of mass. Okay. The principle of continuity states that the mass flow must be constant at all points in steady state flow. The conservation of mass states that the mass of system remains constant regardless of any changes in its internal energy or other properties. So I'm just interested in time. So this is the formula that mass flow rate is equal to density of water into velocity of water into area of hole, but I have not defined the area of the hole. Velocity. Now we know the velocity, we know the density of water, we do not know the area of hole. I think the answer will be in terms of variables. Okay, yeah, as I can see, you can see that I did not define the area of the hole, so it's using that variable. So so after using this formula, we will be getting time. So let's put in some values. Therefore, the time takes for the height of the water to become half of its original value can be calculated by this formula. So I'm not going to calculate it. So as you can see that I have solved the whole engineering problem using ChatGPT. So yes, ChatGPT can solve. I think it was the problem was like not that much tough. It was still a simple engineering problem, but it is very impressive to see that ChatGPT is explaining each and every steps, and if you can more specific, it can give you accurate results as well. So that's it in this video. I had planned to solve two problems, but we will start to solve this in maybe in next videos. Anyways, that's it for this video. I'll see you in the next one. Thank you for watching this video.